So hey guys, in today's video, we'll be talking about some basics of current and electricity. So we'll start off by some basic definitions like charge. So charge is basically determined by the number of electrons in deficit if the body is positively charged, or the number of electrons in excess if the body is negatively charged. So what the statement means that charge is basically the algebraic sum of the positive and negative charges. So if you think about it, if a body has like this one positive charge and two negative charges. So if you just do simple math, so you'll get something like one, right? Because like minus two plus one, or minus one, sorry. So you get minus one, right? Because minus two plus one is minus one, which means that there's an excess of electrons, as you can see, because there's more electrons compared to the number of like protons, because protons is positively charged. Therefore, the body is negatively charged. Now, if it was something like this, if there are two protons, one electron. What this basically means is now since there are two protons and one electron, so these two get cancelled, so you get one. In this, there's an excess of protons, but there's a deficit. Deficit which means basically it's less. So there's a deficit of electrons because there's less in this case. Therefore, it becomes one. So if there's like a deficit of electrons, the body is positively charged. And if it's excess, you know that the body is negatively charged. So pretty simple. And another important thing is the charge on one electron is minus 1.6 into 10 raised to minus 9. So basically, this is the charge on one electron. So this basically means that one electron holds a value of minus 1.6 into 10 raised to minus 90. So now there are two electrons, which is going to be 2 times this, right? There are two electrons. One holds this, so two would hold two into this. So this would be very important in like later questions and stuff like that. And another important point to note is that in an insulator, the charge is static, which basically means that the electrons don't flow. Charge is static. Oh, just a second. Charges can. Yeah, so basically in an insulator, the charge is static, which means the electrons in this do not flow. Do not flow. Handwriting is a bit bad, please. Yeah, do not flow. And in this, the electrons can move or flow. Basically, because metal charges the electrons in like a metal, if you see, because metal is a good conductor of electricity, it has a large number of free electrons on it, which can move throughout the volume of the container. So it's like an important point to remember. And another important definition is current. So current is defined as the rate of flow of charge. So current is defined as the rate of flow of charge. In other words, the current flowing in a conductor is the amount of charge flowing per second through the cross section. So if this is like a wire, if like some charge is flowing, let's say X charge, it's flowing in, let's say 10 seconds. So the current is basically the rate of flow of charge, right? So it's the amount of charge you do X by 10, which will give you the current, because X by 10 is the rate of flow of charge, because this much of charge is flowing in this much of time. And current, if you go back to the definition, the rate of flow of charge. So I'll just give you the formula. It's I is equal to Q by T, where Q is the charge, T is the time, obviously, time, and I is current. Yeah. So now, basically, this is measured by an ammeter. So it's a device used to measure current, and uh, it's usually measured in a series circuit. And the unit of this is amperes A, which is basically coulombs per second. Now, obviously, coulombs is basically the charge because it's per second. So this is the charge quantity and this is time. Yeah, so that is current. And current, an important point to note is current is a scalar quantity. So current is a scalar quantity because when like two current collide, the sum is an algebraic sum and it's not a vector addition. So that just like, you just need to remember that. Understanding it, I think would be like a little high level. So basically, just say that current is a scalar quantity because when two current collide, the sum is just an algebraic sum and not a vector addition. If it's a vector addition, then it's a vector quantity, which means vectors basically it has magnitude and direction. Scalar is it only has a magnitude but no specified direction. So another concept is potential difference. So it's defined as the amount of work done per unit charge. So potential difference is defined as the amount of work done per unit charge to make charge flow from one end of the conductor to another. So basically, if this is a conductor, basically this is a conductor. If charge is flowing, let's say from here to here, from one end to another, so the amount of work done per unit to make the charge flow is from one end to another is basically the potential difference. And another name for potential difference is volts. So the formula is volts. So just by seeing this, you can understand that, like this is the correct formula because joules is work done. It's used to measure work, and coulomb, as I explained earlier, it's used to measure charge. So like if you ever get stuck, just think about this because it's like if you get like a multiple choice question, like what's the formula for volts and you've forgotten it. You know that if you remember the potential difference, the definition, it's the amount of work done per unit charge. So obviously the amount of work comes on top, right? Because that's the first statement. And work is what? It's joules. Work is always measured in joules per unit charge. And charge, as I said, it's in coulomb. So you can just, like get this formula just by doing that. And volts is measured by a voltmeter, which is connected across those points in a parallel circuit. So that's one thing. And the next thing, important concept is resistance. So the obstruction offer to the poor. That's the official definition of resistance. Basically, if this is a conductor and if charge is flowing like this, so you have like some electrons flowing like this, resistance will basically try to block this flow. So it's just going to block this flow. It's going to resist it, which means it's not going to allow the current to pass. It's just going to slow it down. And it's basically this quantity is measured in ohms. And the symbol for this is the omega sign of the Greek letter. So basically, this is called the omega, and this is a Greek letter. And so there's a law revolving around this. It's called the Ohm's law. So I'll just write it down. Ohm's law. Yeah, so this is basically Ohm's law. This in Ohm's law, this is volts. This is the current. And this is the resistance. So basically Ohm's law, and this law basically states that the current flowing through a conductor is directly proportional to the potential difference across the conductor. The derivation of this is basically if I draw a graph of I versus V, which is the current on the y-axis and the volts on the x-axis, it's going to be directly proportional, right? Because according to Ohm's law, they're directly proportional. And if you find the slope, which is the rise upon run, the inverse of that, so the inverse of the slope is 1 by resistance. So that's how you get this resistance, the value, the quantity resistance, basically, because you find the slope and inverse it. So you get the slope is basically the inverse of the resistance. And actually, this is how resistance was found out. So it was an experiment, I'll just write. Yeah, experimental quantity. And the thing is with Ohm's law is it only works if temperature is constant. So that's like, one independent variable. You could take this as an experiment, no, sorry, that's a constant variable. Yeah, so constant variable is temperature. And while doing your experiment, if you're trying to find out the relationship of IV, V versus I, and find out if it's like directly proportional, make sure to include that you're keeping the temperature constant, because if temperature is not constant, you won't get the same results. Since it's a constant variable, you need to control it throughout the experiment. Now let's talk about the factors affecting the resistance of a conductor. So the first factor is the material of the conductor. Material of the conductor. So why is this? It's because different materials have different concentration of free electrons present in it, and therefore the resistance of a conductor depends on its material. So basically, substances which have like a large concentration of electrons offer less resistance, therefore they're called good conductors. So if there's a conductor, let's name it conductor A, there's conductor B. So you have two conductors, both of them are conductors, which means they both conduct electricity. But in A, there are 1, 2, 3, 4. There are 5 free electrons, and in B, there are only 2. We can say that A is a better conductor or good conductor of electricity because it has more amount of free electrons present in it. And since B has like a negligible amount of free electrons in it, it's a bad conductor. Bad. Because like if there's like a negligible amount of free electrons present in it, then it offers high resistance. And since I previously told you that resistance is basically the obstruction of the flow of current, right? The obstruction offered to the flow of current, which means that if there's more resistance current, there won't be a proper flow of current. Therefore, this is termed as a bad conductor. Now, some bad conductors are rubber, glass, wood. Good conductors are silver, etc. Silver is the best conductor of electricity, but since it's very expensive, it's not used in like wires. Aluminium is the next best, so aluminium is used. And another factor is the length of the conductor. So this is if in a long conductor, the number of collisions of free electrons with the positive ions will be more as compared to a shorter one. Therefore, a longer conductor offers more resistance. Basically, if you have two conductors, again, let's say A, let's say B. If current is flowing through both, that's the flow of current. And if they're like electrons present, this would take more, the current here would take more time to reach the end because it's going to collide with these electrons, right? And in here, because its shortage is going to reach faster. The best way to think of this is that if two cars start, there's A car and there's B car, and these are two roads. One is like a longer road, and B and A is like a longer road, B is a shorter road. If a car is starting and if there's traffic, obviously A car will take time because there'll be more cars present since it's a longer road. So he'll need to go around, he or she will need to go around here and there to get till the end point. So it's just going to take more time. And B, because the road is shorter, less cars, it's going to go very quickly. So therefore, B offers less resistance, less, while A offers more. So that's another important factor, the length of the conductor. The next is the thickness of the conductor. So another important part is the thickness of the conductor. In a thick conductor, electrons get a larger area of cross section to flow as compared to a thin conductor. Therefore, a thick conductor offers less resistance. Because if you, again, take the road example, if you have a road, two roads of equal length, let's say road A, and this is road B. They have equal length, just like assume they have equal length, but B is wider than A, obviously, according to the diagram. So, and if like car A wants to reach here till the end point, car B wants to reach to the end point, some amount of cars, okay, let's say these are the cars. if you just think about it, logically, car A would take longer time because, the traffic here is more congested. So it's going to take more time to reach the end point because the road is very small. But car B, on the other hand, since the road is so big, the traffic is spread out, the cars are spread out. So it's just going to like easily get to the end point in less time. So if the thickness of the conductor is more, then there's less resistance. If the thickness of the conductor is less, there's more resistance. So an inverse proportion. Another important thing is the last and final thing, the temperature of the conductor. Another very important factor. Basically, in this, with the increase in temperature of a conductor, the random motion of free electrons increases. As a result, the number of collisions of electrons with the positive ions increases. Hence, the resistance of conductor increases with an increase in temperature. What this statement basically means is just again go to like the road example. I think that's the best when talking about the four factors. So road A, road B. Assume they have equal length, they're equally wide, and they're made of the same material. It's saying, but A, it has a higher temperature. This side. Let's mark this in like red, higher temperature. Red is like hot. This has a lower temperature. So B has a lower temperature, A has a higher temperature. Because the definition says the random motion of electrons increases. Because according to the kinetic theory, as temperature increases, the atoms start vibrating faster, they start moving around faster. Their collisions basically increase, because that's why, like, if you see a liquid turns into gas, because once you add heat to it, the motion of the particles of liquid, they start to like become more active and they break the intermolecular force because they start roaming around, start vibrating faster. So in this, if you see, if you use the same car example, if there are some cars, because it's like there's like a lot of energy, the cars are just like in top speed, they're just going here, they're just going there, they're like all around the place. It's like imagine like a busy day, it's like a sale or something, 5-10 cars just coming here and there. But B, on the other hand, since it has less temperature, the electrons are like stable, they're not moving that much. And if you wanted to reach the end point, which route will you take? Obviously, you take the B route, because since the cars are like stable, can easily like maneuver around them, reach the end point. But here, since cars are all around, there's like really chaotic, frenzied environment. It will take time because one car will crash into here, just gonna like overtake you, this, that. So it's gonna take much more time. So that's why as the temperature of the conductor increases, the resistance also increases. Because again, just keep coming back to the definition of resistance. Resistance is defined as the obstruction or offered to the flow of current, right, by the conductor. And that's why, so if the temperature increases, the resistance increases, temperature decreases, the resistance also decreases. So that's like a direct proportion. And that's it for today. Next time I'll be back with more stuff. We'll be continuing this chapter. Thank you.